to this year's practice award is awarded jointly by DAS and SDP, as I mentioned, to the best example of decision analysis practice as judged by the award committee. And the purpose of the award is to publicize and encourage outstanding applications of decision analysis practice. We are very fortunate this year to have a strong committee composed by Laura Keating from SDP, Patrick Leach from SDP, who unfortunately could not be with us today. He's teaching right now, but has sent his assessments. By 𝑷𝒂𝒂𝒂 from DAS, who has been the co-chair and indeed this year has led all this process. So we are very grateful to Nadia for leading the award organization. And by me, 𝑔ilberto_Monteibler, representing both DAS and SDP. I also want to mention the amazing support that we received from the SDP team, particularly by Diana Swift and Hilda Sherik-Jan. They were amazing in organizing everything, including this webinar. Let's just remind ourselves about the practice award criteria. As an innovation this year, we're going to ask each one of you to let us know your preference in terms of project. It's a consultation only, so it's going to take into account by the judges, but it's not going to be shared with the participants, the candidates, and also not with the public. So the criteria are clear framing of the decision using the principles of decision theory, the quality and originality of the decision analysis techniques employed, the centrality of the analysis to the client's decision-making process, and finally, the benefits of the decision analysis to the client, stakeholders, and the public, take into account the importance of the problem. So these are the 4 criteria that we are going to assess the projects on. And the 3 finalists, among several applications or submissions that we had, we selected 3 very strong projects. And we are very thankful for the teams and the presenters that are sharing these exciting projects today. So the first one is going to be fostering participation and knowledge construction processes in real settings through decision analysis and collaborative value modeling. The presenter is Mônica Oliveira, and the team members are Carlos Antônio Bani Costa and Ana Vieira. The second project is a decision support for portfolio capital allocation for internal capital market at Dow Chemicals, and the presenter is Saurabh Bansal. The third one is a multi-attribute decision model to evaluate potential investments in near-Earth object detection technologies. The presenter is Ralph Keeney, and the team members are Thomas Pali, Victor José, Asa Pali, and Mario Jurek. Each project is going to have 20 minutes for the presentation with about 5 minutes of questions from the judges. Please feel free to ask questions. The judges are going to read them and may ask them. And if you can, stay until the end so we can ask for your opinion about which project you think is the winner. Okay, now we can start then, and we're going to follow this order. So the first one is Mônica Oliveira. I'm going to stop sharing my screen, and Mônica, you have 20 minutes, please.
Well, good afternoon from sunny Lisbon. I'd like to greet the members of the jury and the audience. And of course, I'd like to thank this opportunity to share our work and thank this recognition from the 2 societies. So I'm presenting our project, Fostering Participation and Knowledge Construction Processes in Real Settings through Decision Analysis and Collaborative Value Modeling. So who are we? We are a team located in the Engineering School of the University of Lisbon. The team is composed by me, Ana Vieira, and Carlos Bani Costa. We are decision scientists working in the Decision Science and Management Engineering group. This group has been originated from the work many years ago and the creation of a team by Professor Carlos Bani Costa. So in this talk, I'm going to start by describing which was the rationale for us to create the collaborative value modeling framework. It was set to address the challenge of effectively engaging many stakeholders and experts in real decision analysis processes. And of course, the focus will be in 6 distinct and, in our opinion, very successful applications. For you to understand why collaborative value modeling appeared, I'm going to show some background information. So we work within the socio-technical school of face-to-face decision support that combines technical elements of MCDA with social aspects of decision conferencing. So our work is embedded in the principles of multi-attribute value theory, cross-consultation, and socio-technical design. And what we'll be presenting in here, we believe collaborative value modeling strengthens and consolidates this school of thought. So for you to understand some of our applications, we need to make a very brief description about the social and the technical component of our work. So in the technical component, we have been enhancing and working with multi-criteria value measurement with Macbeth approach. It's an approach that has been developed several years ago by Carlos and his co-authors, and well, which is what is in the core of Macbeth is the construction of a quantitative value model from elicited qualitative value judgment. So technically, we tend to make questions on pairwise comparisons, asking for qualitative judgments that are the starting point to move towards Macbeth value scale. So several of our applications make use of these protocols, and you will see later on. From the social component, for many years, the group has been working in face-to-face settings with groups in decision conferences. Of course, that decision conferences tend to combine group facilitation, judgment modeling, and information technology. There are several requisites in which we work. We work with specific conference room layouts. We make use of different process designs that depend upon the number of people operating, and typically the groups are not large. In the right side, you have examples using small groups or larger groups within decision conferences. Well, in many cases, we started perceiving that we could do better or in a different way in some cases. So in cases in which there are time limitations of participants, in which we need to manage the resources and the effort, and when participants in our contexts are geographically dispersed, it is very difficult to work only with decision conferences. And so we have seen this as an opportunity to do it differently, to have different concepts and different tools, and to work in a better engagement of participants. So that led to the creation of collaborative value modeling that combines large-scale participatory web Delphi processes with smaller-scale face-to-face processes to promote agreement in different modeling stages of an MCDA. I'm not going to enter into detail, but of course, collaborative value modeling is rooted in literature from MCDA, from collaborative knowledge acquisition, and of course, in the social area from decision conferencing and Delphi. So I will give a few words about Delphi. While we have been used to work in face-to-face settings, when participants are located in different areas, they have more time constraints, and we need to engage a much larger number of participants, we found out that Delphi processes that involve a sequence of questionnaires anonymously, in which in different rounds participants can give their opinion in the first round. In second round, they see their opinion, the other people's opinions, they can change opinion, they can make comments. This provides a way of enlarging participation, collecting knowledge, and empowering the collaboration. So collaborative value modeling is embedded on the idea of making use of 𝒂𝒏𝒊𝒄 processes that are delivered in a web format and can be empowered by platforms like 𝒂𝒄, with whom we work. And that information can be obtained in an expedite way and be combined with multi-criteria decision conferencing. And this combination of non-face-to-face and face-to-face approaches can lead to better collaboration. Of course, this requires facilitation, the use of appropriate decision support systems, and also we use in 𝒂𝒏𝒊𝒄 and decision conferencing the same protocols of questioning. They embed the process design and all these things. So having said this, now the presentation will move to the real applications of collaborative value modeling. Collaborative value modeling can be applied in different modeling stages. Within this presentation, I will show you examples of real applications in which collaborative value modeling has been used to structure the problem, specifically to identify options, to help structuring an evaluation model, that is selecting indicators and identifying value aspects, and also to inform the building of evaluation models through finding value function shapes and weighting. So in the remaining of the presentation, I will go through these real applications that were carried out to address the challenges of our clients, and our clients have been very diverse. So the first challenge that has led to the creation of the collaborative value modeling approach was the 𝒂𝒏𝒄𝒂 project, in which we were asked to build a population health model that could evaluate the health in European regions and help designing policies to improve health and health equity. The second real application was to the Brazilian Forum for Climate Change, that had to prioritize measures to reduce carbon emissions, to inform the Brazilian government on how to, what could do, which type of actions could be done to reduce carbon emissions. This work was done following the Paris Agreement. Our third case is a corporate case. Galp is our oil and gas company in Portugal, large, and had the challenge of selecting an enterprise management system, and so we helped them building a model. Our fourth application follows a project in which we're asked to lead the process of defining which policy recommendations could be followed to improve sustainability and resilience in the Portuguese health system. A fifth application, we have been working with Portuguese hospitals and with our regulator responsible for health technology assessment to work together on the evaluation of different types of medical devices. And in the last case, we were challenged to build, to help people building a national consensus in the field of immunology. So, of course, I don't have time to go into detail in each of these applications. So the idea is that I'm going to select some features to understand how we have applied decision analysis concepts and tools, and of course, collaborative value modeling to answer to the challenges. So, in the European project, 𝒂𝒏𝒊𝒄𝒂, we had the challenge of embedding a large number of people in building a model to evaluate population health, and all those people were located in different countries. They were specialized in different areas, socioeconomic, in health care delivery, in different areas of population health, and we wanted to use sound methods to inform model building. Of course, there was the part of evidence, and we were responsible for the multi-criteria modeling, and we have devised different types of 𝒂𝒊𝒄 processes to inform indicator selection, selecting the value functions, understanding qualitative weights, and that was set to inform a decision conference with a smaller number of people. But for doing that, we had to use other type of tools, and to illustrate two of these we have had to use to develop a decision support system for group curve fitting to Macbeth judgments, that is making use of Macbeth judgments from the 𝑬𝒏𝒊𝒄 processes into group curve fitting so that it could help the decision conference. Additionally, because model testing was challenging, we have used concepts from geography and web geographic information systems to help sensitivity analysis, model testing, and validation. So, in the second project, to help the Brazilian Forum for Climate Change in prioritizing measures to mitigate carbon emissions, there was a process of, number one, defining a large number of mitigation and carbon mitigation and reduction of carbon emissions, and we have devised a questionnaire in which we could ask, in this criteria, the added value of this measure is, and using, for example, a Macbeth-based qualitative scale with a negative and a positive part to understand whether the measures would have an added value, a positive or a negative. This information collected from a large number of people was, of course, the starting point for a decision conference that really benefited from that previous knowledge acquisition and, of course, was enhanced by the views of a much larger number of people. So the recommendations from this case were afterwards led to a report from the forum that was sent to the Brazilian government and was the starting point to select the reduction of the measures to reduce carbon emissions, and that was the starting point also for the government to define national determined contributions. Third case, corporate case. So when a company selects an enterprise management system like Galp, faces the challenge of setting the characteristics, the features of the management system, and the management system is to be used by a large number of people, and being used by a large number of people from many departments, there was the challenge of getting their knowledge, the features about what they wanted from the management system, and to promote also convergence in their views. So here you have an example of a 𝑬𝒏𝒊𝒄 process in which it was used for eliciting Macbeth qualitative swing weighting judgments, and that information was used, the 𝑬𝒏𝒊𝒄 was run in 3 rounds that gathered convergence in participants' views, and after convergence on qualitative swing weights, that information integrated the decision conference in which a Macbeth-based model was built to build a model to evaluate alternative enterprise management systems and inform the selection of the best enterprise management system. The fourth case was from the Partnership for Health Systems Sustainability and Resilience. This is an initiative from the World Economic Forum, LSE, and AstraZeneca, and with local partners in Portugal from Philips and KPMG. And after analyzing the system, we were asked to set a process to involve a large number of people, not only to define policy recommendations to improve sustainability and resilience, and also to promote a policy dialogue. So after 11 top experts making recommendations in 7 domains, what we devised was a 𝑬𝒏𝒊𝒄 process for extended discussion of those recommendations. In that process, what we did, we have involved 40 top-level stakeholders and experts that not only provided their agreement about each of the 69 policy recommendations, but also commented. So given that we have the opinion about the recommendations and the comments, we have combined the 𝑬𝒏𝒊𝒄 with dialogue mapping tools so that we could have not only the policy recommendations, but also the rationale behind those recommendations. And so we have used a problem structural method in the process, and that has led to the selection of 43 policy recommendations that gathered an agreement from a large number of stakeholders, and that included professionals, ex-ministers, academics, patients. And from this, there was a national discussion that went to the press and in several forums about the need and relevance for implementing those policies. The fifth case, we worked with the health technology assessment regulator in PharMed and hospital partners to help them to reflect upon the added value of different medical devices. So here I would like to focus on one feature of what we have done. We perceive that answers to the 𝑬𝒏𝒊𝒄 could be influenced by the type of information that was fed to participants, whether participants received the views of all the people participating, or by groups of people, that is, knowing the opinion of health professionals, academics, decision makers, whatever. And so here I would like to underline the use of collaborative value modeling with features of behavioral research that were deemed as relevant by our partners to understand the answers. Finally, very briefly, in medicine, very often there is a need for setting national consensus. And here we were asked by the Institute for Evidence-Based Health to help them. This was a project for the pharmaceutical industry to help designing a process and implementing it so that there was experts' convergence towards full agreement. So here there needs to be total consensus, full agreement about recommendations. And we have combined 𝑦𝒊𝒄𝒂 with decision conference to the process of into 𝑦𝒊𝒄𝒂 to commenting the recommendations, adding recommendations, revising, voting, and after working in decision conference. So, having shown you the 6 real examples, I would like to say overall that the 6 applications had a very successful impact. They led to prioritization, for example, of measures to the Brazilian Forum of Climate Change. All of those have helped effectively our clients to go forward, to move forward in discussing, prioritizing, building consensus in all the areas. And a second message is that they were effective. The use of collaborative value modeling was effective to engage large number of participants that are difficult to involve in decision conferences. So some final comments about the added value of collaborative value modeling. We believe that looking into these cases, the approach was effective to collect knowledge from a large number of stakeholders. It helped promoting dialogue and consensus. It can be tailor-made to different contexts. It can be combined with different decision analysis techniques. And for sure, in the future, we can develop tools to help its implementation and eventually also adapt it to risk simulation, optimization, and other decision modeling contexts. Thank you very much. We'll be very happy to give you references, publications, if you are very much interested on the topic. And of course, I'll be happy to answer to any questions.
Many thanks, Monica, for the very interesting presentation. So we have time for a couple of questions. I'd like to call Laura and Nadia, if they can turn on their videos. And I wonder if one of you would like to kick off, please.
Yes, thank you, Monica. Great presentation. Let me put my video back on. I wanted to ask you, what do you think is the main contribution of your work? Is it the application of Macbeth to different settings? Or is it the process design element of the work, for example, WELFI and the engagement with stakeholders and experts?
Well, I would say that we have several applications, and all of them have different features. Of course, we have been used to work with MacBeth, and we know that has a very friendly protocol, and it helps very much when we are building evaluation models. So it's a key piece when we build when we apply collaborative value modeling, but collaborative value modeling goes beyond the use of MacBeth. I think it's the process design, combining different elements, 𝒏𝒊𝒄𝒂 that empowers engagement, collaboration, collection of knowledge, with friendly protocols. Without the friendly protocols, you would have problems in using 𝒏𝒊𝒄𝒂 process and decision conferences. And of course, there are several challenges in collaborative value modeling. For example, we know that in decision conferences, we are face-to-face, we can clarify questions. When we do it in a web format, we need to advance and be double careful in anticipating potential problems because we are not seeing. So I would say that it's the process design, using the right combination of methods, and of course, in the right combination of methods, MacBeth is a piece.
And another question, if I may, you have applied your approach to different settings, for example, health, climate, and so on. Where do you think the impact was greater and why?
It's very difficult to say that. Well, we can say that in the case of Brazil, well, Brazil is a large country with very important problems related with the pollution. And so the engagement of a very large number of people, because they are from different sectors, they could participate in the process. And even the decision conferences also involve a large number of people, leading to an agreement about the measures with the higher desirability and doability was very important. Well, so in the Portuguese case, for example, for the sustainability and resilience, it was also deemed to be very effective in making people to discuss within a policy dialogue. And because the policy dialogue was very inclusive, no one could dispute results. So the discussion was about, there is a consensus about these measures. So why we are not doing that? So, well, I'm not prioritizing. I think that in different cases, but of course, the message is that I think that participation and collaboration is key.
Thank you.
Thank you, Nadia. Laura?
Yeah, thank you, Monica. I really enjoyed that. I do have one more quick question, mostly around the decision framing. So if I'm understanding correctly, it seems like that is used for engaging a lot of subject matter experts and gathering information sort of at that stage. But I'm curious about how the decisions are framed in the first place, and if your method includes incorporating all those people's perspectives into the original decision frame as well, or if not, how that's communicated, I guess, in the process.
Well, we have worked with our clients in decision frame, for sure. So not only in the problem structuring, it's that the problem, whom you want to involve, why you want to involve, all that was worked with our clients and was a key piece to be done before the process design. And of course, even the process design was discussed. If we wanted to involve, for example, from our oil and gas operator, people from different departments, the type of methods, the type of communication, how to involve them, all these issues were done following the initial problem. The initial problem was, okay, we don't really understand how to, which features to consider in the evaluation of the enterprise management system. And so following that, we needed to work with our clients for sure in the problem structuring, in decision framing, and after moving to the process design.
Super, thank you.
Okay. Yeah, we have to move on. I have a very quick question, Monica. So these are 6 large-scale applications with kind of sophisticated methods being used. I think a very quick answer, please. So if you think about standard decision analysis, to which extent what you guys have done would be extending and enhancing decision analysis in those applications?
Well, at first, we have some literature saying that very often we apply decision analysis models and they are not adopted, they are not implemented. So we think that that is one contribute that we are building tools that are effective, because if you engage more people in an effective way, it increases the adoption, it increases the acceptation of the model. That is one piece. The other thing is that combining this with existing decision analysis techniques, we think that it empowers their use when those techniques require knowledge from experts, from stakeholders. So, well, the existing techniques can be implemented and built in different ways.
Thank you very much. Yeah. Okay, so now we switch to the second presenter, Sarah, to the second project, please. And Sarah, are you there?
Yes, I am.
Yes. Nadia, you raised your hand.
Yes, we have a couple of questions in Q&A.
I think
so
we
can
must
ask
move
Monica,
on.
yeah, if I can ask Monica to answer the questions via
Sure.
chat,
Thank
via
you,
the
Nadia.
chat facility, that will be great.
Thank you, Nadia.
Thank you.
Monica. Okay, Sarah, the floor is yours. 20 minutes maximum, please.
Thank you, Gilberto. Hello and welcome. My name is 𝒂𝒏𝒂 Bansal. I'm going to talk today about a decision support for portfolio capital allocation for internal capital market at Dow Chemicals. It's a mouthful. There are three specific themes: decision support, portfolio capital allocation, internal capital market, that I'm going to expand on during the presentation. I also want to express my sincere thanks to Mohammed Tanveer, who was instrumental in starting this project at Dow AgroSciences, Dow Chemicals, and seeing it through completion. A loose outline of my talk is as follows. I'm going to first provide contextual details of the project. As decision analyst, a lot of times the tools that we develop, the techniques that we develop, they are specific to the context. So I want to explain the contextual details of the internal capital allocation program at Dow. That followed by, I'll talk about what were the solutions we developed for this contextual situation. I'll also talk a little bit about some of the prescriptions that we tried and we considered that didn't quite work out. So I want to talk about both what worked, what did not work. Subsequently, I'm going to talk about the changes in the decision-making process as an outcome of this project, followed by some of the benefits that the firm has seen in the past. So what is Internal Capital Allocation Program, or ICAP as it's called at Dow Chemicals? Typically, all large firms will put aside a significant kitty of money at Dow AgroSciences, at Dow Chemicals. I'm using interchangeably because the managers were from Dow AgroSciences, but we are working with Dow Chemicals. At Dow, they every year they allocate about $400 million for projects that are meant to improve their performance internally. These projects, when we look through the details of these projects, they belong to one of three buckets. One bucket was new products. So these are not innovative R&D products. These are derivative products. For example, Dow already has a chemical that it sells in a specific market, and a customer comes along and says that, can you please modify it for us? So that's a derivative product. So that was one kind of a project that will be captured in the ICAP program at Dow. New processes, one of the examples that we had, a very interesting example that we had was Dow was trying to change the way it manufactures things to reduce worker injuries. So again, that is a new process that will be covered in one of these projects for the program. New services, an example was Dow was trying to figure out whether it should offer a service to individual farmers where they test the soil and then say, based on your soil, this is the seed you should be buying, this is a fertilizer you should be buying, this is a pesticide you should be buying. So together, the hope is that these small projects will improve the firm's bottom line, both in terms of increasing the revenue and decreasing the cost. But the intangible benefit Dow felt was that a lot of times, for example, the safety improvement programs will make Dow a better employer. Dow also felt that managers, when they try to work through these projects, they have a sense of sort of ownership and autonomy that they really like, and that makes Dow an exciting place to work. From the manager's perspective, what are the incentives? Most of the incentives were intangible that slowly over time turned into tangible benefits. Because this is a competitive program, managers felt that if they are able to get a project through the program, this adds to their reputation. And if they're able to get these projects successively for a few years, then that will naturally lead to their career progression. Some managers also said that the process of submitting a proposal, getting it approved, seeing it through the process gives them valuable experience that they benefit from. Now, I want to focus on 3 details of this program. First is timeline. So as I mentioned, the total kitty that a DAO has available every year is in the ballpark of 400 million. The way the allocation works is as follows. What you see on the screen is the timeline for projects with the annual cadence. There are some projects that are multi-year projects, but those were few. A bulk of the projects were single-year projects. And so the way these ICAP program would work is that in months 0 and 1, which is December and January, the ICAP program will invite requests for proposals. And there will be 2 items in that. First, what's the scope of the project and what is the cost? Once DAO has these details, it will use a portfolio optimization model. The reason why they use a portfolio optimization model is that while the total money available is 400 million, the total ask across all the projects is in the ballpark of 600 million. So DAO needs to choose which project it's going to fund and which project it's not going to fund. So they do that using a standard portfolio optimization model. So that's what happens in months of 0 and 1. Months of 6 and 9, somewhere in those months, there will be a midpoint check-in where managers whose projects have been approved, they will come, they will present their findings. They will also talk about how much money they have spent. Do they need more money? Do they have extra money that they could return back and so on? And in month 11, the project sort of concludes where managers come back and say, this is what we have found. Here is the conclusion. Here is how much money we ended up spending on the project. The last item that I wanted to mention was that from the perspective of decision analysis, 2 interesting features are as follows. First, because this is a competitive process, there was a natural incentive for managers at the 0 to 1 month mark to engage in what some of our colleagues would call a motivational bias, that there is a natural incentive to lowball the cost to get the project. And then what they will do is they'll show up on a 6 to 9 month mark and they would ask for more money. The second item, because that is interesting and relevant to us, is this nature of aleatory uncertainty in cost. That even when a manager is not trying to engage in a motivational bias and try to systematically lowball their cost estimate, even if they try to very diligently come up with a cost estimate, it's just an estimate. Just like project management, the actual cost invariably is going to be different. Sometimes it can be more, sometimes it can be lost, it can be larger than that, but there is an inherent aleatory uncertainty in that. Now, the way this program was structured, and because of these 2 decision analysis artifacts, the program was facing some issues. So again, let me remind you what was happening was that DAO in the months of 0 to 1, if it had $400 million to allocate, it will allocate all those amounts in months 0 to 1. Managers trying to get their projects in, they will lowball their costs. Some of them will lowball their cost and get their projects accepted. On a 6 to 9 month mark now, there is a problem. A lot of managers will come back and ask for more money. Their rationale would be that, hey, cost is uncertain. It's an aleatory uncertainty. So it just so happens by chance that the actual cost is greater than the estimate that we gave you. So from DAO's perspective, they quite weren't able to figure out whether it's a natural variability that is causing this or a motivational bias that is causing this. DAO also had a problem that because they had spent all their $400 million, anytime they needed to find more money, they had to go to the CEO to ask for more money, and that wasn't a comfortable conversation. The last item was that DAO's original philosophy of allocating all the money was that, we have 400 million, we'll allocate all of them. Some projects will need more money, but then some projects will be done in lesser money, and so it'll even out. Well, it never evened out because there was no incentive for managers to return the extra money if they were able to finish their project earlier and in lower cost than the original estimate. So in light of these challenges, our mandate was to come up with ways to administer this program so that A, motivational bias is mitigated. That is, managers have an incentive to truthfully report whatever their cost estimates are. And also, if it so happens that some of the managers are able to finish their projects in lower cost than original estimates, there is an incentive to return the money because that will improve the efficiency of the program. At the same time, there was a recognition that there is an inherent variability in the cost, and we should make sure that when a manager tries to do their best, provides an accurate estimate as to the best of their ability, and their cost happens to be just a little higher, it does not penalizes them unnecessarily. It's not punitive in nature, that it's an aleatory uncertainty that is beyond their control. And the last item that ICAP really wanted to do was to say that, look, we don't want to go back to our CEO on a regular basis and ask for large chunks of money. So we want to manage this process a little bit better. So in light of these challenges, we first turned to some knee-jerk reactions and some classical DA recipes. But we realized that each one of them had some weaknesses. For example, our first knee-jerk reaction was that, don't allocate any money at the 6 to 9 month mark. Over a period of time, managers will learn that if they try to game the system and lowball their cost just to get a project, it's still not going to be beneficial for them. But that couldn't fly at Dow because managers said that, look, for some projects, there is this natural reason why cost is higher than the estimate. But these are still good projects. So we don't want to lose those projects also. So that's why this recipe couldn't fly. We also tried to use the classical recipe of saying that, look, let's quantify the motivational biases that specific managers or divisions have exhibited using historical data. Just compare how much they asked, how much they actually spent eventually. The gap is their motivational bias. And when they give us a new estimate for the coming year, we just reduce it by that. So this had some merit, but it didn't quite completely eliminate the need for second allocation. And the idea that we still want ICAP program to not be going back again to the CEO wasn't quite addressed. Also, there was a perception that managers actually, once you tell them by how much you're going to adjust their estimate, they'll continue to game the system even more in different ways. The third item that we considered was what is called clawback in industry, where if a manager's estimated performance is lower than the actual performance, in this case cost, then there will be a monetary penalty on them. Dow did not want to do that at all. They thought that this will be bad for employee morale. We are trying to encourage innovative R&D practices in our firm, and this will just put a damper on it. They again wanted to also emphasize that some of these costs happen to be high just on account of inherent variability, and we should not be charging money to people based on this act of nature, so to speak. So eventually, the solution that we came up with had two parts. The first part was to quantify the aleatory uncertainty in cost, and we used that to essentially say that in the future, when Dow has $400 million to allocate, it should not allocate all the money up front. It should allocate a large fraction of that money up front, but then keep some money in its back pocket to allocate at the 6 to 9 month mark. And the second part that we did was what we call a rolling horizon cost period, in which we say that let's come up with a way in which we will take the motivational bias, but then tweak it in a little different way and continue to operate a rolling horizon calculation. Hopefully that will nudge the managers to not estimate their fudge their numbers by a lot, but also provide them with an incentive to return surplus amount. So let me go through some of these details rather quickly. So the way we quantified aleatory uncertainty in cost is as follows. What I've shown you on the screen is a snapshot of the data that we had, project IDs, managers, groups, years, but two most important things. What was the initial cost estimate for a project that was approved, and what was the final cost? So we took the ratio of final cost to the initial cost, and then we regressed that on a bunch of factors like managers, groups, years, and so on. And this regression had two advantages. The first advantage was that the betas, the gammas, and thetas that you see on the screen, these coefficients will quantify motivational biases for managers and groups and just fixed effects for year-specific effects. So that was the first benefit, that we were able to identify where some of the items are biased, which divisions managers tend to be biased. Maybe they are motivational, maybe not, but that's okay. We don't need to sort of tease into that. The second benefit was that the standard error of the regression allowed us a better way to figure out how much money they should be allocating. So for example, using the standard error information, we were now able to simulate what will happen if Dow chooses to allocate entire $400 million upfront. And as the graph shows you here, if Dow allocates entire money upfront, there's a 55% chance that they will need to go and ask for more money from their CEO. So maybe they shouldn't do that. They should allocate 300 million. Well, when you try to allocate only $300 million, what happens is that you'll never need to go and ask the CEO for more money, but you probably will be wasting some money because the odds are that you will not end up using all the money, remaining money at the 6 to 9-month mark. So maybe what you should do is allocate 360 million upfront and keep 40 million in your pocket. That still leaves about 10 to 12% chance that you'll need to go and ask for more money from your CEO, but the odds are that you will be using all of your money also in a reasonable amount of time. So this is one of the pieces of the solution that allows DAO to use its money efficiently without having to go to the CEO again. The second item was a rolling cost credit calculation. So let me show you a mathematical detail and walk you through it. So basically what it says is that if a manager submits a project this year, I'm going to adjust their cost estimate. Here is how the adjustment is going to work. I'm going to take their cost estimate that they have turned in this year, plus if they asked for more money last year, I'm going to inflate their cost this year by a fraction of that amount. Less, if they returned me with some money last year, then I'm going to deflate their cost by a bit this year as a fraction of that. So specifically, if we look at beta 1, which is a penalty for seeking more money last year, if we set the parameter of value to 0, it means there is no penalty. On the other hand, if we set the parameter of value to 1, it means that there is a massive penalty for asking money. Now, our concern was that because of the inherent aleatory uncertainty, this fraction should not be 1. Why? Because otherwise you'll end up penalizing those managers who just had a bad draw of luck. So overall, the value of beta 1 should be somewhere in the intermediate range between 0 and, but certainly not on the corners. Same goes for beta 2, that you are trying to provide a credit for good behavior in the past. So if the value is 0, there is no incentive. If you are giving a value of, sticking in a value of 1, then a manager who hits a jackpot on one project this year will have an unfair advantage next year. So maybe the value of beta 2 should not be 1. It should be somewhere, it will be lower than 1. Now, I wanted to also mention that while this kind of adjusted cost estimate has an intuitive appeal, recently with Shivam Gupta, we are also able to show that this kind of mechanism actually is what is called in literature as epsilon Bayesian Nash equilibrium, which means that once you try to execute this over a long period of time, things will prevail such that managers don't have any incentive to systematically change or distort their cost numbers. The firm is able to operate at a near optimal point to the best of its ability. It does require a lot of mathematical calculations using Hobdin inequality, a class of consideration inequalities, to establish the performance bound, which is the epsilon, which is infinitesimal amount. But again, I won't go into those details. The central message here is that this adjusted cost estimate has strong analytical foundation, because of which it also makes sense academically and analytically. Now, in terms of how are these actual values of beta 1 and beta 2 are calculated, lots of simulations and lots of managerial discussions. The first item, let me just walk you through beta 1. The first item that we showed to managers was the following. The graph that you see on your screen, on the x-axis is beta 1. So you can increase what fraction of penalty you want to impose. Y-axis is the probability of selection next year. So as beta 1 increases, the probability of selecting a project next year goes down if you misbehaved this year and you asked for more money. So the two lines that you see, they are shown for C hat plus 1 sigma, which means your original cost estimate was what it was, and then you asked for money that was equivalent to 1 standard deviation away. The lower line is for 2 standard deviation away. And so the point is that the more your ask is in the last period, the lower is your probability that you'll be able to win a project this year. So this is sort of the implicit way of penalizing them. Now, managers wanted to make sure that, again, this is not punitive because there is a variability in cost. At the same time, they wanted to choose a value of beta that will still be a deterrent from engaging in motivational biases and engaging in low cost estimates. The second item was what sounds fair. A penalty of 90% sounds extremely harsh. A penalty of 5% probably does not have any teeth. So that was an internal discussion that they had. We were on the sidelines watching this discussion, trying to figure out what sticks, what does not stick. The value that they used for beta 2 was again based on a similar consideration. Now, so to sum, these two parts together address the issue of motivational bias, but also allowed DAO to better handle this aleatory uncertainty in the project submitted. The new DA-based process had two different steps. So in the old process, they would get project proposals from managers. That still happened. However, instead of allocating all $400 million upfront, they were allocating a large fraction of that, keeping some money in their back pocket. Also, they were not using the cost estimate as is. They were changing those estimates and then putting them in the optimization model for portfolio allocation. In terms of impacts and benefits, let me focus on just 3 items. The first item was that because DAO was not allocating all the money upfront, there was a lower need to go and ask for more money. So in terms of 2 metrics, there was a 35% less chance that DAO will need to go and ask for more money. And then even if DAO had to go and ask for more money, the conditional value of that money, that additional ask, will be much, much lower. This is what is called CVAR, conditional value at risk. And we found that the reduction was up to 30%. The second dimension was that the performance of the program improved dramatically in terms of efficiency. And the reason why, we found 2 reasons why it happened. The first reason was that because there was an incentive to return extra money, people returned extra money. So overall, $20 million were returned. I won't go into the details of this conditional VAR of 290 and how it compares with 20. If I have time during Q&A, I can explain that. But money was returned, and that improved efficiency. And second, DAO was able to find better projects because motivational bias had gone down and actual good projects were shining up. Lastly, in terms of other intangible benefits, DAO benefited from knowing what is the innate variability in project cost, which divisions, managers are more likely to inflate the cost. Managers, when we talked to them, they said that they thought that the process was fair because it's less likely people will game it. They also were happy that they won't be overly penalized if a project happens to be very expensive just randomly. We at the bottom, what I've noted is, and this is my second last slide, I'll conclude in a minute. We have written technical articles using this material. We talk about this in our classrooms, and we have given this presentation in a few practitioners conferences to talk about this simple DA prescription. So to conclude, we were faced with an interesting situation that had motivational bias and aleatory uncertainty that overlaps with the behavioral decision analysis. We were able to use some of the motivational bias theory and extend that in different ways to come up with a prescription that was practical, that is analytically sound and rigorous, and that has led the firm to observe a bunch of monetary and non-monetary benefits. So that is what I have. Thank you.
Many thanks, Saurabh, for a really interesting project. So now we have Laura and Nadia back for a couple of questions, please. Nadia, do you want to kick off?
Yes, thank you, Gilberto. Great, Saurabh. Good to see you again. I wanted to ask you, many of us, we have been applying decision analysis to different settings. And from time to time, we've had to tackle capital allocation problems. So I was wondering to what extent you would be able to generalize your results. Do you think we might be able to observe the same behavioral patterns across sectors, across geographic regions? Because what you seem to be doing is you use analytics to solve and fix behavioral aspects. And I was wondering, and maybe a quick comment at the end, whether all of us, we can work more closely with HR managers because there appears to be a cultural issue within a company.
Yes, so that's a great point. So to what extent the results are generalizable to other contexts? I think the place where the results are definitely generalizable are whenever you have a sequential decision making. This wouldn't be an issue. In many ways, this opportunity wouldn't be there if they did not have the 6 to 9 month check where there was an opportunity for managers to come and ask for more money. So whenever we have sequential decision making, I think it is inevitable that some of these things will come in. Whenever, in whichever context you have people clamoring for scarce resources, it's essentially a resource allocation problem, we will run into these issues. I know Don Clements has written a few papers on how to optimally allocate resources. So what we are looking at is very, very generic there. But to your point about how to work with HR, let me broaden that a little bit. So I want to sort of take this opportunity to talk about this, what is happening here. So what I'm showing you here is that suppose Dow had allocated only $360 million. How much money, analytically, normatively, how much money Dow can expect to get back? So for that, if you try to just calculate the conditional value of all the projects on the left-hand side of 360, that value is 290. So what that means is that Dow should expect to get $70 million back from those projects, because these projects will be done at a lower value than the money that was allocated to them. But we only got back 20. So what explains between 20 and 70? That's where the culture comes in a little bit. That's where also understanding what is happening. So in project management, there is something called Parkinson's law, which means that if people have a lot of money, they start spending money sort of quite loosely. And I think that is perhaps something that is happening here. Also, we weren't quite able to figure out who was returning the money and to what extent they were returning the money. And I think that also has a strong cultural component to it, that cultural, not in terms of nationalities, but more in terms of some companies have the culture of being responsible with their money. And there, the managers are quite likely to return more money. On the other hand, some companies, like I once worked with a technical high-tech company, there the money transactions are a little loose, and those managers are less likely to return the money because there is a lot of money to go around. So, just to summarize, yes, company culture matters because that will dictate whether people will be returning this money or not. And second, wherever you have managers competing for scarce resources, motivational biases will be there. Whenever you have sequential allocation of money, you will run into this issue of needing more money at the middle point.
Thank you. Just to flag that there are a couple of questions in Q&A. So at the end, Saurabh, if you take the time to answer directly, thank you.
Thank you, Nadia. Laura?
I do have one quick question. I'm curious about the softer side of it, I suppose, and how, if you know, how this was, I guess, like unveiled to the employees, if it was described to the managers, this kind of process that would be happening behind the scenes, and if so, how was that received? And was that helpful for changing behavior?
Good point. So, let me go back to this. So when they socialized this with the managers, they had to make sure that there were two concerns. The first concern was that there is a class of managers, and we don't know who are systematically engaging in this behavior. And to them, the message was that, look, you might get lucky, and if you get lucky this year and your project happens to be done with a lower cost, wouldn't you want to get benefit for that next year? On the other hand, there were all those managers who were frustrated that some of their colleagues were fudging numbers to get a project. The message to them sort of was that, look, this is a reasonable way in which the other managers will be disincentivized from misbehaving. But yet, don't worry, if your project happens to exceed the cost because of a random outcome, you won't face that severe of a penalty. So I think it had to be two-pronged, because otherwise, if you only give one message, then essentially you are also saying, we think you are a manager who does this thing or that thing. So the message had to be together, that this is the reason why we have both these things going on.
Okay, thank you, Laura. Yeah, I have just a quick question, Sarah, because we have to move on. Really interesting project, and I think the beauty here is to bring these behavioral issues as a prescriptive tool, so not just describing behavior, but actually trying to reduce the motivational bias. Very quick question, because we have to move on. So if I understood well, you have this in this rolling budget, people get a credit or a reduction based on their estimates. If you think about this long term, we know that from prospect theory, losses are more painful than gains. Do you think that prospect theory could eventually, over a large number of budget years, skew this behavior?
I did not find any evidence for that there. And there might have been a few reasons. The first reason was that managers do get promoted fairly quickly in firms, like every 3 years they move. And but at the same time, within that one, this is done on an annual basis. The losses, if they're experienced, they are experienced at the 6-month mark, 9-month mark, 11-month mark. So that is temporarily, that's a very strong separation, is what I felt.
Thank you very much. Right, so now we move, thank you, Nadia and Laura. Now we move to the third talk by Rolf Kinney. And Diana, if you can share his screen, please.
I think you can hear me now, right?
Yes, we can. Thank you, Rolf. We'll have 20 minutes maximum, please.
Thank you. Well, it's a pleasure to be here and represent my co-authors. Our discussion is about a multi-attribute decision model to evaluate potential investments in near-Earth object detection technologies. Next slide, please. What's the problem we are addressing? Well, near-Earth objects are basically asteroids, sometimes comets, but we're concerned about asteroids. And the decision is about whether or not and how to limit asteroids' damage to Earth, because they can cause a lot of damage. The picture on the left shows the implications of a small asteroid hit in Siberia in 1908. It totally wiped out 800 square miles of forest. And the power of that is 1,000 times more than the atomic bomb that was dropped on Hiroshima in World War II. Now, the other end of the scale, a large asteroid hit a part of Mexico, the Yucatan Peninsula, 65 million years ago. That eliminated dinosaurs on Earth and many, many, many other species. So next slide. And it happens that near-Earth objects are categorized into 4 sizes. You can see them here, small ones up to about 140 meters, and the large one 5 kilometers or more across. And their implications when they hit Earth obviously goes up to be much, much larger with the higher size. So people tend to be concerned about the bigger ones. In particular, we have a government program that says we should search for all those asteroids that are out there, but don't worry about the small ones. So just the 3 other sizes was the ones of focus currently. Next slide. Who are the stakeholders here? Well, this work was not funded by anybody else. We decided we wanted to do this work, but there's the B612 Foundation, founded by a couple of astronauts, and their goal is to protect our planet from asteroid impacts. So they were interested, and we certainly talked to them and got some information from them that was worthwhile. Congress is certainly a stakeholder and potentially of interest because they passed the bills mandating that NASA should track and find all the NEOs that are bigger than the small ones. We've got 35% of those when the goal was 90%. And NASA would be interested too, you think, and then people on Earth, because we're subject to being hurt by these. Next slide. That's it. Thank you. There are ways to prepare for this, and one is to identify where all the NEOs are, and the second is to figure out how to move them around if they're going on a path that looks like they're going to hit Earth. And how do we find out where they are? Well, telescopes, basically. Historically, we've used things like the one in Hawaii and everything. Currently, there's the upper right picture, a brand new one being built in Chile that the US is involved with, too. That's very clean air down there and better to pick up things. And a third thing that's proposed is a telescope that would actually be out in space somewhat, not way, way out there, but way above our atmosphere, and you could see things more. That's the one, the proposed NEO surveyor. Now, to avoid astronauts hitting Earth, there has been an experiment with this using DART, the picture on the right and mentioned at the lower left, and you basically go up and bump it with a bomb-like effort and move it out of the pathway that would hit Earth. Next slide, please. So what are the alternatives here? Well, there's the alternative that we could just not put effort into this. And the cost of that over the next 50 years is we'd just cut down what we've now been spending. It would be $100 million. We could continue the current efforts for 50 years. All this is on a 50-year plan, be 600 million. Or we could really invest more and really use the Chilean telescope too. That would be 1.3 billion, and then 2 billion if we included the space telescope. Next slide. So here is the decision that we're looking at here. We've got the 4 alternatives I just mentioned on the left, and then over the next 50 years, there's a threat, and there's whether or not it's detected. So there could be no hazard, meaning over that 50 years, no NEOs are aiming and or hit Earth. And then there could be the small, medium, large, or very large one that could come. We could detect it way ahead of time or not. And then there's the mitigation decision at the end. Suppose we detected one. Well, we can try to avert its path by sending something out, like the DART system, and moving it around. Or if that didn't work, or somehow we didn't have that option that would work, then we can try evacuating the area it was going to hit. And that could work or not work out well. Next slide. So what are the objectives to evaluate this? It's obviously a multiple objective issue. One is saving lives. 2 are economic. 1, minimize the damage from the NEO, the economic cost, and minimize the cost of the system that you're using to reduce the damage. And then the 4th is really the environmental impact and to diversity of animals, etc., and plants. And then there are 2 others about scientific knowledge and development of technology. Now, what we want to do is, of course, get a multi-attribute utility function for this. And in this case, it's reasonable that we have a multi-attribute linear, an additive function. Next slide. There's the function at the bottom. And the reason why this is the case is the impacts are very important. The difference between, say, 1 death and 2 deaths is really twice as bad. Linear is a pretty good assumption there. And for the amounts of money over the periods, it's reasonable to assume that's fairly linear also. And for the percentage of species eliminated in the 4th one, 2% is roughly twice 1%. And then the way we construct the next 2 scales, as you'll see in 2 slides from now, are such that they can be put in here in the additive function very reasonably. Next slide. So here's for the constructed scales. Obviously, the 0 level is you don't do much on each one. So it's no funding in X5, and that leads to nothing. Or development of new technology. Again, that's the worst. And the best, we gave a utility of 1 down at the bottom, and then 2 other levels you could have, you put in between it. And for instance, with new scientific knowledge, reasonable judgment suggests that with this knowledge was 0.2 on the scale of 0 to 1 for the utility, meaning the value we'd expect it to offer to our society. And then the 3rd level there, with the Rubin telescope, it would increase it to 0.6. Now with the new technologies, the same type of ideas. You ask, what are the impacts you might have at some different levels there? And then where would they fit on that scale from 0 to 1, which is the standard scale you set up here. And you can see what the results are there. Next slide. There's an awful lot of parameters in this. Here's a couple that we mentioned before, but 58 separate parameters, and I'll show you in a moment some of the results of running things. And many of them don't matter too much. But the time horizon considered is 50 years, as I mentioned. The evacuation success rate would be 80% if we get to where we have to do that. Value of a statistical life, we use 1.97 million per person. Obviously, you want to do sensitivity analysis of that, and there are plenty of issues there. Environmental evaluation, 2.26 trillion for the elimination of 1% of species on Earth. And then the range for the two constructed scales, you can see, we thought was worth 700 million and 500 million. Next slide. So here's some more parameter estimates, and some of these are important. The likelihood of a small asteroid hitting Earth in the next 50 years is 0.02, or roughly 2%. The cost of mitigation, billion. The number of people who might be killed in, the estimated expected number, maybe 11 million. And there's a description of it there. And the bottom, probability of successful mitigation, if detected, 78%. Now you've got the same types of things here, but if you look at the very large one, the likelihood of that occurring in the next 50 years, much, much, much less. A slide to show some of that too. But the consequences are clearly much greater. Next slide. So, estimates of the percent of NEOs detected over the next 50 years from now, given various alternatives. Well, currently, we only have identified 3% of the small NEOs that are out there. 33% of the medium ones, and over 90%, and particularly 98% of the very large ones. Now, if we just stopped efforts, that's where we are now. If we continue with the current efforts, we're going to recognize few more of the asteroids and jump to 11% on the small ones, but you can't improve too much on the very big ones, but it does to over 99%. And for the large ones, up to 99 too. And then with the Chilean Vera Rubin site, they can jump much more, 69% of the small ones, and you can see the others there. And with the Space Telescope too, jumps even more. Next slide. Oop. Here, this shows two things: what the likelihood and negative utility of different impacts would be if they hit Earth. And you can see the small one up there these are log scales on both of the axes. It's much more likely to occur. As we said, it's about, in 50 years, 2% or so. On the other hand, if you look at the very large impactor, its likelihood of occurrence is very, very low. But the impact of the very large one is 5 orders of magnitude of the very small one. And the order of magnitude of the small one occurring is 4 orders of magnitude more than the very large one. So from that information, you would tend to think, well, the expected damage per year is roughly an order of magnitude greater from the large ones than the small ones. So we understand why the small ones aren't looked at. But what happens, that really isn't exactly the situation. And next slide. If you look here at the contribution to the total expected utility over the next 50 years, the small ones lead to more problems. And the reason is, it's 1.5 times, or a little more than that, orders of magnitude more that you will not pick up the small ones. And you're picking up most of the large ones. And so this was really kind of a surprise finding, that the most expected damage in the near future, given what we know now and could do now, is really the smaller NEOs. So an important implication here, Congress should change the guideline that NASA shouldn't look to identify all the really small ones, and NASA should maybe put some pressure on to do that. Have that done. Next slide. Here's just the type of analysis you can do here. Here's the analysis of the best policy as you vary the statistical life. So again, the one we used is about 2 million. And if you look at 2 million there, which is just a little ways to the right from the left side as the map goes, all the alternatives are closely, roughly the same in the implications there. But each of the alternatives has a little range where it's best. And the real ones that are key is if the price is very low on statistical lives, optimal is to just go through and cut out our expenses. On the other hand, then there's a range when other two, and then if you get down to where the value of a statistical life is more than, say, 5 million, then all of a sudden, both of the big new efforts, the Chilean one and the space telescope, are important. Next slide. Now, we did some sensitivity analysis with just simple triangular distributions over all of the 58 model parameters. And again, most of them don't turn out to matter much. But when we plot the probability distributions of their expected utilities for 1,000 iterations, one can see here that the two that involve Chile and the Space Telescope in general are much better. They really peak on the right than the other ones do. Next slide. So what are the contributions of this work? One, it really indicates that and how important insights can be inexpensively developed through some thoughtful analysis of important decisions. This wasn't a massive year-long effort to support it with tons of people. Second, it suggests that a program run by NASA, likely to discover the smallest NEOs, would be certainly effective and potentially avoid some serious negative outcomes. It provides useful information to the 𝑏612 Foundation because their purpose is to really protect our planet from asteroid impacts. This certainly provides information for them, and we talked to them about this and got information from them that was useful into the model to help do this. And it indicates the value of an analysis that's really commonly faced by all nations, but it doesn't have much political implications to it. And it's maybe a place where nations that don't cooperate much might be able to cooperate sometime on such a problem. Next slide. Why is this work important? Well, one, it indicates that a small group of decision professionals can make some important contributions on very large problems. Doesn't mean that anybody will accept any of those ideas or think hard about them, but it certainly increases the chances if they're out there. It indicates that decision analysis, our field, and the related fields like risk analysis and operations research have an awful lot to offer our country and our society. And these fields should be much wider known than they are. And we hope we've encouraged that we have uses for these models. And certainly anyone who's listening to this could work on and develop a model like this. It's fun, it's interesting, it's worthwhile, and I'm sure you can do it. And we certainly enjoyed doing this, and it was a pleasure to be invited to present it here. Thank you.
Many thanks, Rolf. So again, let's call Laura and Nadia for questions.
Sure.
Laura, want to keep?
Yeah, I can. Maybe I'll take. I see one question in the chat. Maybe we can do that one since we're at the end of the presentations here. So, question from Robin Keller. Did you consider that multiple NEOs of different sizes might show up in the next 50 years?
Well, it's possible, but the likelihood is extremely rare of different sizes because there's only 2% chance, a little over 2%, that the small one may show up and the others are much, much lower. So no, the basic analysis didn't really look at that for that reason. But you could easily enough do that. I think it would show that the difference in doing that and not doing that would be very low in any implications, however.
Thank you.
Sure.
Nadia?
Thank you, Ralph. That was great. And you gave us many details about the technical aspects of the work. I wanted to ask you about the impact. You mentioned the Congress is a stakeholder. And I was wondering if there is an end goal and if you have any plans to influence policy or inform policy in the US one way or the other with this kind of work?
Sure, we'd love for that to happen. And what we need to do is take that work and really put it into a written form that would be most valuable for the various groups you'd like to influence. Some would be, in a sense, the whole paper, or at least a summary of, and some might be an awful lot shorter. And there's the potential for, say, an op-ed on something like that too, that would, be something that might initiate people to look more deeply into it. I think that would be the general procedure that would be worthwhile to go. Try to get a group interested in general. Wow, never thought about that type of impact, and then move forward with a little more detail. But that would be terrific. Yeah, the ideas, I think our ideas, the five of us, always would be interested, if we could, to have some positive impact. Not that we expect people to do exactly, quote, what the model suggests, but it suggests that here's how you could think much more clearly about the things that may be relevant for you to do.
Thank you.
Sure. Thank you, Ralph. That was a truly global problem, so really interesting, and it's cool that the kind of counterintuitive solution was the one that actually showed the biggest benefit, if I understood well. So that's really interesting. I have a difficult question. You don't need to answer it, but I was just looking at the $200 trillion that the big program would be required. And I was thinking that maybe this should be compared as a portfolio problem against other global issues like global health and global poverty. So how would you address this if the decision were actually where to invest $200 trillion on global issues?
Well, certainly that's, if I understand the question, that's one they need to think about, because when they're thinking about if we should put more money into protecting ourselves from near-Earth objects, and if it's a lot of money, then obviously that's not going somewhere else, and that's a different decision than the one we're making. But the people who are spending that money, of course, should think of where's the best place to spend it. Now, just observing at least the US Congress, I think a lot of times they don't make those comparisons. Something happens, it's politically important at the time, it gets press and everything, and we're definitely going to do something about that. And you saw we didn't have a political objective in our model. And I think many of the people who make those decisions, at least in our country, have a lot of weight on the political objective in their models, which aren't maybe explicit. So it's tough, but it's still helps to have the model, because you can make the arguments if it's reasonable investments.
Definitely. Thank you very much. So just to conclude, we should thank Rolf Kinney, Mônica Oliveira, and Sarah Bansal for the fantastic presentations, and for participants and the teams behind the projects, the judges that were here, Laura and Nadia, and also Pat, and the amazing support from Diana. And we are delighted to have had such 3 strong projects. It's going to be a tough decision for us, I think, as judges. And we will let you know in the Informs conference, right, Nadia?
Monday.
@𝒂𝒓𝒔𝒄𝒂.
Yes, on Monday, the 16th of October. So join us in the afternoon. I think it is at 4 o'clock local time.
Thank you very much, and all the best.